Hi everyone, I'm here to explain what you are doing today for the I Can See Clearly Now virtual light lab. Unfortunately, I'm not able to be at school today. My mother-in-law who watches my children cannot come today, so I have to be working from home. So please watch this video to help answer any questions that you might have about the assignment before reaching out to me via email. So the first part of this lesson is to learn a little bit about what lenses are and how they're used to correct vision. So a lens is any type of transparent material that bends light. Most manufactured lenses are made of glass or plastic. The bending of light is called refraction. As parallel rays of light pass through a lens, they are refracted in such a way that they either come together, which means converge, or spread out, which means diverge. The thicker and more curved a lens is, the more it will refract the light rays, the more it will bend the light rays. The point at which the converging light rays meet is called the focal point. So when all the light rays come together, that's called the focal point. The human eye contains its own lens. In an eye with normal vision, this lens is able to focus light rays on a retina, creating a clear image. Sometimes this lens of the eye cannot focus properly, and this creates vision disorders. Farsightedness is the inability of the eye to focus on a nearby object, and nearsightedness is the ability to focus on a faraway object. Lenses worn in front of the eye can correct vision disorders by either spreading or bringing together light rays enough so that the eye's lens can focus them on the retina. In this lab, you examine the refractive properties of convex and concave lenses and apply these properties by selecting appropriate lenses to correct various vision disorders. So some of the objectives of this lab are to describe the shape and refractive properties of convex and concave lenses, explain how lenses are used to correct vision, describe conditions of nearsightedness and farsightedness and be able to identify them, and apply the knowledge of properties of convex and concave lenses to correct vision disorders. So you are essentially becoming an optometrist where you are looking at different patients, 6 different patients, and diagnosing what their vision problems are based on what they're able to see. So on this slide, it shows you normal vision versus farsighted, so you can't see right in front of you, and normal-sighted versus nearsighted vision, where you can't see far away. So this is a diagram of different lenses and what their shapes look like. So a concave lens are thinner in the middle and thicker on the edges. It may be curved on one or both sides. Concave lenses cause light rays to diverge or spread apart. Convex lenses are thicker in the middle and thinner on the edges and may be curved on one or both sides. Convex lenses cause light rays to converge or come together. So you can see that this one is thinner in the middle, thicker on the edges, thinner on the edges, and thicker in the middle. That's the big difference between the two. The human eye contains a flexible convex lens that focuses light reflected from objects onto the retina. The muscles surrounding the eye change the shape of the lens to allow it to focus properly. Depending on how close or distant the object is, rays that travel through the lens converge at a focal point. So they come together at the focal point. All these focal points lie on a focal plane on the lining of the eye, which is the retina. So the light comes through your eye, hits the back of your eye, and that is your retina, and that is how you're able to focus your images. The images on the focal plane is upside down or inverted, but the brain translates that inverted image into the view we see. So for farsighted, sometimes the lens of the eye cannot focus light properly on the retina. In the farsighted eye, the eyeball may be too short and the focal point falls behind the retina. The farsighted eye can see distant objects clearly, but nearby objects appear blurred. Another type of farsighted starts at the age of 40 when the lens begins to lose its flexibility and ability to focus on nearby objects, causing a need for reading glasses. Lenses can correct vision problems by bending light rays before they reach the eye, in effect moving the focal point of the eye's lens so that it falls upon the retina and creates a clear image. Convex lenses cause light rays to converge and shorten the focal point for the farsighted eye. Concave lenses cause light rays to diverge and lengthen the focal point for the nearsighted eye. These lenses cause greater refraction, so thicker lenses correct greater degrees of near or farsightedness. So This is really important. Convex lenses cause light rays to converge for people who are farsighted, and concave lenses are for people who are nearsighted. Lenses can correct vision problems by bending light rays before they reach the eye, in effect, moving the focal point of the eye's lens so that it falls upon the retina and creates a clear image. Convex lenses cause light rays to converge and shorten the focal point. For the farsighted eye, concave lenses cause light rays to diverge and lengthen the focal point for the nearsighted eye. Thick lenses cause greater refraction, so thicker lenses correct greater degrees of near or farsightedness. So now what you're going to do is, based on that reading, is you're going to fill in this table. So for convex lenses, does the light bend in or out? Does it converge or diverge? Insert a picture of this lens. You can just use Google. And what kind of vision is it used for? And this says it all right in the reading that we just went through. And then again, for concave, does it bend in or out, converge or diverge? Insert a picture. And what is it used for what kind of vision? The next part of this lesson is you are going to actually go through some patients and you are going to watch a video about how a doctor would diagnose vision problems and what type of lenses that person would need to be able to see. So there are 4 or 6 patients, depending on what version of the assignment that you have. You're going to click on the video and you're going to watch it. Mrs. Ianzelli is actually the one talking in the video. She is going to be going through the different lenses and the different thicknesses, and you're going to be able to see what is going to be clearing up that person's vision. So based on what is in the video, you're going to find the distance to the object, the type of lens that is needed. So is it convex or concave? What thickness do they need? And what are they, farsighted or nearsighted? So you'll go through the video, go through the demonstration, and you're going to be doing that for all 6 patients. So we have Rosie Iris Nazelli, Corinia Danino, Lensley Odgers, Vicky Retinizzo, Lashley Pupils, and I, Elizabeth Worsham. Funny names. I know, they're funny. And then once you're done diagnosing each of the patients, you're going to answer some of these analysis questions. So 5 and 6, 7, 8, and 9. Okay, so once you go through all of these patients, you answer all those questions, make sure you're restating and using part of the question in your answer. Make sure all the tables are filled in, and then you can submit it. This is, again, worth a test grade. If you have any questions, feel free to email me. But please make sure you're watching this video first. I'm trying to cover a lot of the information here. Go through all the patients in their order. Thank you. Have a great day. Bye.